Okay, once again, very good afternoon for everyone, and very good morning those joining from Europe side. And we thank you for joining us in today's webinar. I will start with a small introduction about myself. My name is Vaityanathan, and I'm one of the director in IC Pro, who is leading the automation and digitalization solution provider to customers around the world. Currently, I'm stationed in Singapore and taking care of Singapore operations. So we are extremely happy to have you here today. Today's webinar is more of a presentation with a knowledge sharing platform in which we are trying to introduce the best class of technology, products, and solutions in the world to our customers with the latest technologies. Just a little bit in terms of housekeeping. In case most of you all already is mute. Just in case if you are not in mute, please mute yourself. The overall webinar is planned for about 50 minutes. And in case you have any questions along the way, please feel free to write it in the Q&A box, which you can see on your right side on the Q&A tab. And then we will try to answer most of the questions, if not all, at the end of the presentation. In case we are not able to answer, we will always try to get back to you in the other forms of email or any other channels. I hope everyone is able to hear us. In case if anybody have a problem, can't hear, or there is any technical issues, please use the chat button to write to us. We will try to communicate with you parallelly. And at the end of that presentation, you can give us your feedback, and we will let you know how we can provide us a feedback at the end of the day. With this, I think we would like to start the webinar. This is jointly organized by IC Pro and Crosser. Just to give you a small introduction about IC Pro itself, IC Pro was started in 2009, and then since then we had multiple stages of going through our development cycle, wherein we have started manufacturing control panels, and then we set up overseas office and grow into the multiple verticals in terms of oil and gas or infrastructure and other pharma, food and beverages and other areas. And we set up our office in Singapore, and subsequently currently we are also set up our office in US, just in case if some of you do not aware of it. This is just a small introduction about our IC Pro. Of course, I think most of you know about IC Pro, and particularly about today's webinar. As you all know, the future of digital transformation depends on many technologies like IoT, AI, ML, low-code platforms, robotics, etc. At IC Pro, we help our customers to build an intelligent automation ecosystems using many of these technologies, tools available in today's market, and achieve a best business transformation. Today, we talk particularly about IoT technologies, and it's easy to implement in your business. IC Pro always committed to provide the best of the class products and solutions to our customers, and we identify a reliable, easiest and flexible low-code platform for IoT applications, which will bring business systems and IT systems together. Today, we are proud to present Crosser, an IoT edge software platform, a visual programming plus low-code platform tool, which is 10x faster than compared to other IT solutions in the development and implementation part. It also helps our customers to reduce the resources required by a significantly 50 to 70% to manage service the entire platform. And it also provides centralized management of various interfaces, communication systems are added to the benefit of the IoT platform itself. So this is a quick introduction about the overall presentation itself. Today we have our presenter, Mr. Adria Manico, who is our Director of International Sales and Partners from Crosser. Without further ado, I would like to hand over the platform to Mr. Adrio to take over with a small introduction about yourself and proceed with the agenda of today's webinar. Thank you. Once again, we welcome everyone. Thank you and have a great day.
All right, thank you for the initial introduction. Nice to meet everybody. So my name is Andrea, working for Crosser, based in Sweden in Europe. My role is a business role, so working with a lot of clients in a lot of interesting projects around the world. And my plan is to share some of these stories with you during this webinar. It's always great and interesting to hear real cases, so I'll definitely put some time on that during the webinar today. The topics that I would like to cover are presented in this slide, so I will start by an introduction also of the company to explain what we're doing, the role of edge analytics, which is becoming more and more fundamental in many projects out there. And in that context, I will present the most typical use cases that we see at our customers. So we've grouped that into 10 main use cases. And out of those, I will then pick 2 case studies of real customers that are using Crosser and Edge in production and go through those examples as well. I will also talk about the technology, just to put things into context. So we'll go through the different components of the solution and then pass the ball back to IC Pro to go through a demo and then conclude the webinar and then also leave some time for Q&A. So don't hesitate to ask questions throughout the presentation. You can just write those in the chat window on the right-hand side, and then we will go back to those questions at the end of the webinar. Good, so let's get going. Quick words about Crosser as a company. We are a Swedish software company. We are fully focused on what the industry defines as edge analytics and integration. And I will define that in detail in the next couple of slides. So Crosser is a Swedish software company. We have the main headquarters in Stockholm, which is where I'm sitting today. We also have presence in the German region, in Munich, to cover that region as well. We're expanding fast with the help of partners like IC Pro, so that's a key strategic area for us, and we're happy to have this webinar with our colleagues from IC Pro today. We are also very much focused on the industrial manufacturing space, which represents the bulk of our customers. So all types of industries within the manufacturing space, asset-rich companies in need of real-time integration and automation. So that's where we fit on a very high level as a company. All right, so let's start, let's say, painting the scene here. So as I mentioned, we're very much focused on edge analytics and integration. And the concept of edge is basically bringing a lot of logic or processing closer to the data sources. So instead of doing everything on the cloud, a lot of our customers, they have the need and the requirements to do more locally on premise, on real-time data. So we typically help 2 types of customers. One is the typical plant owner, kind of the industrial customer that is producing something. So basically with use cases within a plant. The second type of customer, which is depicted on the right-hand side, is more the OEMs that produce machineries that could end up in a plant, but could also be mobile machineries and assets in the field. Often the challenges and the use cases are not that different between these 2 customers. It's all about getting data from your assets, doing something with the data in real time, and extracting the relevant insights from these data sources. And we do that with our edge analytics software that I will be talking about later today. So that's on a high level where edge fits. I will go more into the technology, but just for you to have an idea of what we do, we have a solution that runs locally at the edge, which we call a Crosser node. This software is running behind your firewall, is doing all the data processing, the data collection locally at the edge in real time. And we also have a centralized management platform for configuration and lifecycle. So these are the 2 components that I will go more into detail later on. But in essence, it's a solution that is running on premise and that can fit a lot of different use cases. So that's just on a high level on what we do. But going back on the edge, so what is it basically, and why is it important? So the edge layer is again, as I said, something that is happening close to your data sources. And in this architectural slide or picture here, you see the crosser node, which is this local software that is running close to your data sources, your assets. So this software can not only collect and process data, but it can also integrate to the different types of systems that you might have running locally, whether it's databases, historians, ERP systems, MES systems, and so on. So this is really kind of a glue between your OT and your IT systems, and doing all that real-time processing. The software is always the same, and it can actually address a lot of different use cases, whether it's advanced analytics, where is machine to machine, deployment of machine learning and AI, predictive maintenance. So it can really address a wide variety of use cases as well. So that's a key aspect when deploying projects. You don't need to tweak this solution. This is actually ready to enable any type of use case that you're working on. This also means that this software can open up to a lot of different scenarios, depending on the use case. It could be machine-to-machine use cases. It could be machines talking to some OT system. It could be different systems talking to each other, but it could also be a combination of both. It could be machine data combining with other IT data and integrating that with some other system like cloud, for example. So there's a lot of combinations here that could take place. And the solution is based on the fact that we can address all of these combinations with what we define as a low-code system, and I will go more into that. So this is how we fit on a kind of a high-level architectural view, bringing all of these different pieces of the puzzle together with logic in between, and to enable a number of different use cases that our customers are working on. So looking at our customers, I often show this pyramid, and this pyramid presents really the kind of the path that many of our customers are going through into their projects. Yes, there is a lot of talk about machine learning, AI, advanced analytics that you see here at the top of this pyramid, but the reality is something else. The reality is that most customers, they need to start at the bottom of this pyramid, getting the data, collecting that machine data, and starting to work on this data. But data collection is just the beginning of the journey. That's just an enabler, basically. The fun part is when you move further up into this pyramid, starting to transform this data, starting to analyze the data in real time, and then adding more and more logic in order to address those use cases. It could be anomaly detection, it could be doing some more advanced calculations, filters, conditions, all the way to more, let's say, interesting scenarios with machine learning and AI. That's really when you can optimize things. But the journey typically starts from the bottom of this pyramid and goes up towards the top of this pyramid. And with the crosser edge solution, we try to provide value in all of these layers of this pyramid. So that's typically how projects go. Yes, we also have some exceptions. We have customers that are ready to jump to the top of this pyramid. They want to deploy ML, great, but typically it's more of a step-by-step process going from the bottom of the pyramid up. All right, so in this journey, in this pyramid journey that I just showed, we see a lot of different use cases that our customers are working on, and this is what I will present in the next slide. So we've grouped these use cases in 10 different technical use cases. But first, why are customers doing these use cases? It's often to do with optimization. It's often to do with having better insights. It's being more reactive. rather than waiting and do things on a reactive mode. It's about energy consumption. It's about optimizing use of chemicals or raw materials, better efficiency in the production. So those are the drivers that we all know about. And in order to achieve those, typically, it's these 10 use cases that are being implemented. And these use cases are really a mix of cloud-related use cases, which are often a starting point with many customers, where customers want to get data from their OT assets and data sources, do some initial pre-processing of the data, and then send those insights to the cloud. Some customers also want to optimize and reduce cloud costs. So there's let's say a low-hanging fruit there by doing more processing at the edge and then just send the insights to some data lake, and therefore bypassing some of those expensive cloud services. That's a bonus for many of our customers, actually. But some of our customers are actually not ready yet with cloud. So we do see also use cases that are purely on-premise also. So for those cases, it's again about collecting data locally. So if we look at use case number 4, it's about collecting data from your assets, from those PLCs, from your sensors, doing the pre-processing, analyzing the data on the fly, and then potentially integrating with different systems locally, sending work orders to your ERP systems, triggers, and so on, delivering data to some database, and so on and so forth. So use case number 4 could actually be a pure on-prem use case where there's no cloud, or you could also complement that with cloud, of course. So that is a very typical one. And I think use case number 4 is probably ranked among the top 3 most popular use cases. But I can also jump back to use case number 3, which I would say is a common denominator among all these use cases. And that's because the data is often coming in different flavors, formats, frequencies, and so on. So there's often a need to massage this data, to harmonize the data, transform the data, and create possibly a common data model that can then be consumed by a number of use cases out there. So data transformation is key for a lot of use cases that we see out there. In fact, we have very large customers out there that actually start with use case number 3 as the project, actually. So very important aspect when you're deploying your projects. Use case number 5 has to do with condition monitoring and predictive maintenance. This could be very applicable to OEM customers that have distributed machineries in the field, and they want to get the health status of these machines and also predict anomalies, for example. So particularly relevant for machine builders, but also relevant for factory floor environments where you also want to monitor the status of the assets. Jumping to use case number 6, 7, and 8, this is all about implementing more advanced logic. So we see that many of our customers have specific requirements. They want to bring their own logic to these use cases. And they do that by implementing some type of advanced logic. And it could be their own algorithms. It could be some machine learning model, for example. So the Crosser technology is also used as a platform to easily deploy whatever customized code that our customers are developing. And this could also involve use cases like machine to machine, where you want to collect data from a machine, you want to do a very fast calculation, and then write back to the same machine or to another machine in the line, for example. So again, being able to deploy specific logic is also a very common aspect of a lot of use cases. It could be a very simple Python model or algorithm, or something more advanced, or an algorithm like a machine learning model. The concept is the same. Complementing the Crosser tools with more specific logic. And some of our customers are also starting to use cameras out there to inspect, again, anomalies related to quality, for example. So instead of using PLC data or sensor data, deploying cameras that are becoming actually cheaper and cheaper nowadays, and inspecting these images with some type of logic, again, on the edge, on the Crosser tools, and then identifying some anomalies or some characteristics with the quality being produced. And then moving to use case number 9, it's again extracting value and insights. And a lot of customers, they want to collect specific KPIs, often OE related, on the fly as data is being produced, and then send those insights to some reporting or dashboarding tool that they're using. So that's also a pretty common objective out there. And then we see other types of use cases, for example, optimizing inventory or supply chain with track and trace type of applications. We have customers also with specific packaging related use case with with optimizing the palletizing steps and so forth. So a lot of other use cases are as well that we see among our customers. So this is a bit of a snapshot of what we see out there. Often customers are playing with a combination of these use cases. So often it's not only one single use case, but it's a mix and a combination of these ones, sometimes related to cloud, sometimes only on-prem. So we see a lot of different type of flavors out there with use cases. Good. A glass of water. So moving from the use cases, I want to focus a little bit more on 2 case studies. The first case study is, and I will again relate to the use cases. I will talk about a case study that started the project with use case number 3, data transformation, use case number 4 with integration to local systems, and then use case number 9, extracting OE insights. So that's the next case study that I will present. And the company is actually in the field of the process industry, and specifically potato products, commonly known as French fries, that I think most of us have eaten at some point. So Clairabout is a brand that you might not be familiar with, but you've probably eaten their potatoes. Clairabout is one of the leaders, industry leaders in frozen potato products. So they deliver and they produce potatoes for big brands, big labels like McDonald's, Burger King, big chains like Lidl, and so on. So real high volumes of production all over the world, and they export their potatoes globally, basically. So when Clairabout came to Crosser, they had specific needs. They wanted some type of glue to actually link OT with IT. So again, use case number 4, factory floor integration, linking their OT side, their production lines, with some of their systems. And these systems were their own built MES system, their ERP system, and other dashboards and reporting tools as well. So that was the first use case for Clairabout, by just linking all of these pieces with real-time logic at the edge using Crosser. So that was the first step. The second step was actually extracting some key KPIs, OE related KPIs, and then really starting to extract some juicy information out of that and present that in some dashboards. So that was what Clairabout had in mind 2 years ago when they approached Crosser. So today, Clairabout is basically using Crosser alongside different production lines, doing all the cutting, drying of the potatoes that you can imagine is happening in real time. And so deploying the Crosser tools along these production lines at the edge, collecting data, doing a lot of calculations in real time, and then delivering those KPIs to their MES system, but also integrating with their SAP system that they're using locally also. So this is all happening in real time, close to these production lines, but also close to the packaging lines as well. So Clarabout is actually using our software in these two environments, production, but also packaging. And we're talking about millions of tons of potatoes that are being produced. This is really continuous 24/7 production with a lot of real-time data being constantly produced. So that was Clarabout. Very interesting case. We have a case study on our blog if you want to read more about that. The next case study is in another industry, and this one will be more related to use case number 5, predictive maintenance, condition monitoring. It will be related to use cases 7, for example, and also use case number 1, since we have, in this specific case, there is a cloud aspect to this as well. And the customer here is Gebhardt, maybe not a known name out there, but also very interesting customer. Gebhardt is in the space of intralogistics, so warehouse automation. So Gebhardt is basically, let's say, delivering turnkey solutions for warehouse automation. A lot of machinery, a lot of software, a lot of services around that. And basically these machineries are ending up in very large warehousing facilities out in the world globally. So Gebhardt, the Gebhardt use case when they contacted Crosser also more than 2 years ago was that they had all these machineries out at customer sites. What they wanted to do was to have better visibility on the condition of these machines. You can imagine a lot of moving parts, conveyor belts, robots picking packages, moving packages. A lot could go wrong here. So the first thing that the Gebhardt wanted to do was deploy the Crosser software locally by these machines and start collecting data in real time. And for example, vibration data was a key parameter for them to start predicting anomalies or things that could go wrong, for example. So Gebhardt started rolling out Crosser along these machineries at customer sites, started collecting all this type of vibration data, analyzing that on the fly, but also deploying some type of advanced logic to be able to learn and predict things. So the topic of machine learning was also very relevant, using Crosser to also deploy more advanced models at the edge, at customer sites, and be able to detect those anomalies when they would appear. So that's the Gebhardt case, which we also have a blog or a case study in our website if you want to read more. A few words about machine learning and why people are doing that. Well, again, like in the Gebhardt case, it's for anomaly detection, to be able to catch anomalies, to do more local actions, to also address those use cases where latency plays a role. So that's one of the main reasons why machine learning is being worked upon. Video inspection, I talked about cameras previously. That's becoming more and more popular out there. And in order to inspect still images or video streams, often machine learning is being used to inspect these video images. Some customers are also using machine learning for extreme data reduction. So really reducing a lot of the data that is being produced and then send that, for example, to some cloud platform and basically contain the volume of data that is being sent upwards. And then finally, a key reason is actually to extract more value simply. And that could be in process industries, for example, to optimize raw materials, to predict the quality that will be produced, energy optimization as well. So all that has to do with better yields, better output, more efficiency, is often also linked to machine learning use cases as well. Yeah, I think we can skip some of these slides or go through them very fast. So when we talk about process optimization. It's about, again, collecting data, deploying some type of machine learning model, and then often writing back and actually adjusting some parameters in the production in order to optimize those settings, to optimize the use of some raw materials, and then adjust the production accordingly. So this is often happening at the edge without the need of the cloud, or it could also be a link to the cloud. That doesn't really matter. And again, latency can also play a role here in a number of these use cases. Yeah, time is ticking, so we can, let's say, spend a few words on the actual technology that we're doing. So all of these use cases that I've been explaining, all of these case studies, they're being achieved by two main components in the Crosser portfolio. And the first one, as I mentioned at the beginning of the webinar, is what we call the Crosser node. This is a software that is installed locally. This is a software that is extracting data. It could be from PLCs, it could be from historians, it could be from sensors. So whatever type of data source is being collected in real time on the Crosser node, being processed. That's where you will do all that type of data transformation, data analytics. That's where you could potentially deploy some type of algorithm or machine learning model. And then finally, sending the insights somewhere. So integrating that with local systems, like we saw with Claire about interacting with their MES systems, their SAP systems locally, or sending data and insights to some cloud platform, whether it's Azure, whether it's AWS or Google. So the solution is totally agnostic to whatever cloud is being used. So that is the software that is running locally. It could be on a gateway, it could be on a virtual machine. Same really. So that is the part that is being deployed locally at the edge. The second part of the solution is what we refer to as Crosser Cloud. Crosser Cloud is simply the kind of the management layer. This is where you will define the logic that needs to run at the edge. This is where you will take care of the life cycle, the orchestration of the logic. So this is basically where the user interface is sitting. But Crosser Cloud is a pure configuration tool. We never see any type of production data. In fact, if you deploy some configuration from Crosser Cloud, you can actually then disconnect Crosser Cloud. The edge nodes will run autonomously without need of external connection. So Crosser Cloud is a pure configuration and management layer. One aspect that I think is very important, I should stress, is the low-code part of the solution. Our customers love the fact that they can actually get going in days, in weeks maximum. So this is a low-code solution that allows to build your use cases, test the use cases, and deploy them in no time. So this is very graphical. It's a bit like Lego, connecting pieces to each other and building those workflows, those use cases that are needed to be deployed in a very graphical way. So both your IT and your OT staff have a common platform where they can bring data in, apply logic. So your data scientists will have fun bringing their algorithms and so on, working on the data, and then interfacing with those IT systems that you would have to integrate with. So this is just an example of how a flow or a use case could look like, with multiple data sources coming from PLCs, from sensors, processing in the middle, and then modules and connectors to deliver the data either to some cloud or to some ERP system or database as needed. So self-service simplicity is the essence of Crosser, to build your use cases, to use ready-built modules, ready-built apps that we have in our system. So it's a drag and drop environment, and it's also an environment where you can, again, bring your own code, your own machine learning if needed. So self-service simplicity and low code is really a fundamental part of Crosser. And then, of course, once you do this configuration, once you build your flows, We also have tools for mass deployment, for taking care of the life cycle. So what happens when you move from a POC to a situation where you have multiple plants, multiple process lines? So being able to orchestrate, to deploy updates, to deploy new use cases, to change configuration, and so forth. And also those enterprise grade features like versioning, roles and permissions, credentials. So we've built all of that on top of this low code graphical interface that will help you in the life cycle to roll out the solution to any number of nodes, basically. So that's a key aspect when you scale, basically. So that's the second part of the solution as well. Good. I hit exactly 30 minutes, so I'm on time. So I will pass the ball to Bijou for a demo. Word to you.
Good afternoon, everyone. Yeah. So hope you all are excited with our presentation from Andrea. Thank you, Andrea. I'm sure by now you are ready to see the demo part, how this works, right? Seeing is believing, believing is knowing, and the knowing beats the unknown. With that interesting quote from Philip Roth, let me introduce myself. Myself, Biju. I'm representing IC Pro Solution. I'm based at Bangalore. So Andrea had presented about 10 use cases and two case studies from about Clairabout and food processing industry, and Gebhardt, another warehousing management solution, which Andrea has presented. Today, we have developed a demo kit which, to showcase the use case 6, what Andrea has presented for the concept machine-to-machine automation, right? So on the screen, on the right side of this page, the block, the cloud and a small block in that, which represents the Crosser cloud, where you develop the logic, or it can be called as a workflows. And for this demonstration, we have developed the logic for machine-to-machine application. On the left side of your page, you can see the cloud, IC Pro Cloud in AWS, which you can presume that this is a customer-owned private cloud space to configure your user interface dashboard. In a short while, we would be sharing you all a cloud link through which you can access the predefined user interface dashboard developed by our technical team, and you can interact with that lab setup what we have made here. And bottom of this page on the right side, you have the Crosser node. As discussed in the previous session, Crosser node can be configured in any IoT gateway, or it can be configured in a PC with an operating system of Windows 10 Pro or in Linux. So here we have used a laptop to configure the node. The same laptop will be shared to demonstrate you on the Crosser cloud, how we develop the logic for that machine-to-machine automation. On the left side of this, the green and the orange blocks, which represents the hardware setup for the for the two machine models, which will establish some kind of IoT-based automation between them. You may presume that one machine has a Rockwell PLC with a Micrologix 1400 and other one with Siemens PLC with a S7 1200. The demo kit uses a simulator device for triggering the analog and digital inputs to these machines, or you may consider this as a PLC for these machines. Hope that you all got an idea about the lab setup. So now let me hand over to our technical team, Mr. Santosh and Ranjan, who would be deep diving along with you, on this demonstration setup. Thank you all to listen to me. Santosh, you can take over.
Thank you, Mr. Biju, for the introduction. Hope everyone of you ready for the demo session. Requesting everyone to type yes in chat box so that it will be more interactive. For getting a better clarity, I'll show you the general approach for the digitalization solution, how we have to go on it. I'll be sharing my screen. Yeah, this is the general approach for the visualization or the data analytics. As you can see that there are data collection. This is from the plant level. Then you need to work on the raw data for the manipulation or the edge analytic part of it. Then the third part is the data visualization. So you can see the data collection can be done with there will be different sources of data. You can say it in the right side, right hand side, you can see the data source A, as a data source 1 and 2 having data like A and B, and you want to do some analysis, data manipulation on this A and B, then same can be visualized on the cloud. Okay, so this is the third section. So the same way in the architecture, you can see that here we have PLCs like Siemens and Alhambra as a data source. So we need to collect this data from these two PLCs. So these PLCs are working on different protocols. So here in this case, the S7 PLC is communicating via S7 Profinet protocol, and ML1400 we are communicating through Modbus TCP. So as I mentioned in this section, we need to have a networking for collecting the data. So we have a networking between the PLCs, and also this data is collected through a crosser node. The crosser node is nothing but a PC where the crosser node application is deployed. So, and also as Biju mentioned, there is a crosser cloud where we can write a flow logic for collecting the data from the PLCs. Okay. So the demo section intention, what is the goal of this demo is we need to do a machine-to-machine automation. So whenever we are activating a input from the Siemens PLC, we are trying to activate the output of the other PLC. So for this purpose, we have used this Siemens PLC, Alhambra, and these are communicating through a crosser node. And the flow for flow is developed on the crosser cloud, and it is downloaded to the crosser node. Okay. And also we have an interactive dashboard, which is we'll be sharing a link now. So I'll be sharing a link to you. You can log into that link. I'll be sharing the link and the username in the chat box. Yeah, you can log in into this thing. Yeah, you can log in from mobile or your PC. Username is user and your password is user123. Okay, so this is the link for the dashboard. So this will look like this, the dashboard. Okay, yeah, I'll come back to this. Here I'll more explain how we did this project. See, there are ready-made drivers available in Crosser platform where I can use drag and drop these drivers for reading the PLC data. So here we have used S7 read uh, for reading the PLC data from Siemens and Modbus read from the Alhambra PLC. And there are tools available for the data manipulation, like some filtration or addition, those kind of manipulation tools available. And also there are tools available for connecting to a direct cloud platform. So by using all these drag and drop drivers, we have collected these data from two PLCs and made some logic in between, and we are sending to the cloud. That is the Crosser cloud and IC Pro cloud. Okay, you can monitor the data from the Crosser cloud, but exactly what are the data coming. This will be in a interactive dashboard in the IC Pro Cloud. So the dashboard look like this one. I think my colleague Ranjan will be showing the hardware setup to you. Ranjan, you can share the camera. Yeah. So as you can see that there are two brands of PLC we have used. This is Lombardi PLC and the other one is Siemens PLCs. And we have some pre-wired DT inputs. So there are 6 output, you can see that. So 3 input we wire to Lombardi PLC and 3 input we wire to Siemens PLCs. And there are 2 analog inputs with the potentiometer, you can see. This is connected to the Lombardi PLC. Okay, and also there are tower lamps which we connected. This is the output of the Lombardi PLCs. So the goal is when we are activating the input from the first PLC, then the output of the second PLC should be on. Okay, so I think hope everyone received the dashboard. So that we can start a demo. Ranjan, I think you can activate the first input. Yeah, you can see that the input which is activated from 1400. So there is a motor A indication which is reflected. Uh, okay, the second input, if you activate it in the dashboard, you can see. I'll be sharing the dashboard again. I think you can see my dashboard. Ranjit, can you switch off and switch on the? Yeah, when we are activating, it will be visible on the dashboard. Okay. And also there is an analog input. If you vary, then the data will be available here. So you can see that what will happen when we are activating the input from the Siemens PLC. We yeah. When we are activating from the Siemens PLC, the output of the other PLC will getting on. So this is the output wired from the second PLC. So this is the input we are giving on the Siemens PLC. Okay. Yeah, you can activate the second one. And we have given a remote provision, the remote button, which is in the dashboard. So when you activate the output of the PLC will get activated remotely. I can anyone can experience or you can press and experience that button, which is visible to you. Anyone can try and experience the field. Yeah, you can press again so that it will deactivate. Okay, so we will be explaining the flow. This is the demo. Okay, we will be explaining the flow, how this is done in the Crosser platform. Ranjit, can you share the screens of? We'll be sharing the logic, so we'll be getting a low code analytics experience. Yeah, here as you can see that there are ready-made drivers available. So for reading the Siemens PLC, we have drag and drop the S7 driver, and we did some manipulation here, and we are saying whenever I'm reading these input from the Siemens PLC, then I need to activate the output of the 1400 PLC. So the yellow is the Modbus driver. So I'm just making a logic. When I'm reading this input, I need to activate the output of the other PLC. Okay. So I have two inputs I made. So we have made two separate lines here. Whereas you can optimize and make it a single line also. Just for your understanding, we made two lines. Okay. In the same way, this data is sending to a cloud platform. You can see that we are reading the data from the PLC, and we are doing some mathematical calculations or the filtrations here, and we are sending to a cloud. So here you can see, if you zoom it, you can see that it will be a MySQL where I'm sending this data to my cloud, that is ICPro cloud. And the same way we are reading from the fourth line, we are reading from Alam Valley PLC, and we are sending the data to cloud. Whereas the last line, you can see, we are activating the input from the platform, whatever the dashboard you are seeing there. So when I am pressing this button, I am activating the output of the 1400 PLC. So this is the flow. So you can see this is a simple low-code platform where I can write this logic in a maybe a 1 hour time. Okay. So whereas if you want to do it in a high code platform, then you need to have a lot of codes, and it is a time-taking process. And also the advantage here is whatever the calculation you are doing in the edge, and you are doing all the calculation here, and you are sending this data to cloud. So you will be saving a lot of unwanted data in the cloud, and thereby you are saving the money for the cloud storage. Okay. Yeah, that's all from my side. I'm handing over to Mr. Vaiti for the conclusion.
Okay, thank you, Santosh, and thank you everyone for listening to the presentations and also the demo. Hope it was useful. I think we have exceeded the time set for this whole webinar by 5 minutes. Hope I think it was useful, even though we spent additional time. And I think we will move on to any Q&A session. Manoj, is there any Q&A? Anything anybody has posted any questions?
Not yet. No questions received yet. If anybody has any questions, they can even come back through the registered email ID.
Okay, so I think because we did not receive any Q&As, so if there is any clarification or anything that you all want to clarify, please feel free to contact Biju through the email IDs, whatever you have received, or the registration email ID who have sent to you.
Yeah, there's one question that came in that I see, and that's asking about what cloud platforms are supported. So again, just to clarify that, in the Crosser tool, you have a lot of different modules to integrate directly with any cloud service. So we have a lot of customers using different services from Azure, for example. So we have native connectors for that, or towards AWS or Google. So any cloud platform, and we have built connectors also for integrating with those. So that was just a clarification on that. Yeah.
Thank you, Andrea. So if anybody has any other questions, feel free to write to us. And before we close down, I just want to share with you, there is an upcoming next webinar, which is for the based network. Next webinar is on AI-based production, personnel, and forklift tracking system. So the details will be shared with you soon, wherein interestingly you can see how the data can be collected and how it is useful in the factory environment where there is an forklift is moving around, and together with the equipments or human, and you will get more details on this project on this webinar soon. With that, we will like to close this session. Okay, and if there is any clarification or anything follow up that you would like to have, please feel free to reach out to us on the www.icpro.in, or you can also write to Biju, who is our coordinator for this particular session, at biju@c@icpro.in. With that, thank you everyone and have a great day.
Bye, everybody.
Yeah, thank you.
Thank you. Thank you, everyone. Yeah.